Okay, now let us discuss this last topic of this derivation, the last case, and that is the refraction from denser to rarer medium. Let me draw the diagram very quickly. Okay, so here you have the convex refracting surface xpy having refractive index mu2. It is placed in a rarer medium of refractive index mu1. The object is now placed in the denser medium. Okay, and mind you have to place, before I was putting the surface this side, is it not? Why I'm putting it this side? Because always by sign convention the object must be in the left side, yes or no? And now since the object is in the denser medium, so I must put the denser medium in the left side. Understand? So all this I'm doing, I'm not just there's every reason. I mean, there are many reasons. Okay, when you draw the diagram, you don't just draw just for the sake of drawing. You don't just by heart. There are reasons as to why I'm drawing it this way. Before I was drawing it how? I was drawing the surface this way, yes or no? Why? Because I was putting the object here. No, now I'm drawing the surface this way. Now why? Because the object is in the denser medium. You got the idea or not? And by drawing in this manner, I'm always putting the object on the left side of the surface. Okay, on the left side. Why do I do that? So that it will be in accordance with the sign convention. Is that clear? Okay, so here you have the object O, and light rays from the object goes up. One ray of light will go directly along the principal axis. Another ray will go like this. Okay, this is point C, which is the center of curvature, and if you join, you get a dotted line, right? So here you see this angle, this OA. Let's call this point as A. This point here, that's A. So OA, that is the incident ray, all right? And this dotted line is the normal. So this angle is the angle of incidence I. Understand? So now it will refract away from the normal, yes or no? Because it is going from denser to rarer medium. So this is the refracted ray and this is the normal. So this angle is the angle of refraction R. Okay, and this angle here is alpha. I here will be beta, and lastly C, this will be gamma. Distance from I to P, that is image distance V, O to P, object distance U, and from P to C, that is the radius of curvature R. Now mind you, when you take the distances, V and U will be negative. Why? Because they are on the left side, whereas R is positive. So I want you to do this by yourself. I want you to derive this and find out the expression by yourself. Okay, you should get an expression in which the refractive indices has interchanged places compared to the one before, compared to case 1. Alright, and you do this nicely and show it to me. Thank you.